Today we're going to talk about the atom and the structure of the atom. When we look at the way that we came up with this concept of what the atom looks like, this small thing that we have never actually seen the inside of, it's a lot of indirect evidence. But um, when we look at that history of the way it was developed, I'm not going to spend time going through every one of these because you can read this information. But when we talk about the Greek philosophy and Democritus and his first idea of the beginning of that atom, and you can look at how the structure of the atom progressed and Dalton's model, when he revived that idea of the model of the atom in the 1800s, after they pretty much laughed Democritus um, out of the out of his philosophy of what an atom actually was, that it was indivisible. Dalton also thought it was indivisible, that it was just this solid sphere of material or solid shape of material. It wasn't until Thomson came along late in the 1800s and discovered that if you zapped a gas with electricity, you got these negative rays from them. And he determined that there were particles in the atom that he referred to as electron. Well, he actually didn't call them electrons. He called them corpuscles. But he knew there were negative particles in there, so he figured there had to be positive ones in there also. His plum pudding theory was really just that. He thought it was a blob of material. That atom was a blob of material. It had some positive material in it and some electron corpuscles in it that were negative. Now, Rutherford took that idea and he was going to, or he pretty much was just proving that idea, and he set up a classic experiment that gets asked about all the time on SAT2s and AP tests and everything else, where he emitted some alpha rays from a box and he struck a piece of gold foil. Now, he anticipated that all of those alpha particles would just go right through that gold foil and pretty much land on the other side. But what he found out really astonished him. He found out that some of them were deflected and some of them were actually bounced back. He said it was the equivalent of having a 15-pound mortar shell being bounced back by a piece of tissue paper. So that it just blew apart their idea of the atom, because they knew that there had to be something in there that was incredibly dense in the atom. And since alpha particles are positive and they were being bounced back, he determined that that very dense part of the nucleus had, or excuse me, part of the atom had to be positive as well. And that's when they discovered the nucleus of the atom, which we know contains the protons, those positive protons. It wasn't till later that the neutron was discovered by one of Rutherford's assistants. So with those pieces of information, we have talked about now the discovery of the three main particles of the atom that we talk about, the protons, the neutrons, and the electrons. Bohr took that a little bit further and he said, it's more like we've got this positive nucleus in the center and these electrons are orbiting around that nucleus like planets around the sun. And so again, he had a more specific idea of what those electrons were doing. And it wasn't till then, even later, but look how much closer these discoveries are coming one after the other. Erwin Schrödinger came up with the concept of the quantum mechanical model. This has to do with probabilities of electrons being in energy levels, and these energy levels being in specific positions, and this whole three-dimensional idea of the atom based on waves. We'll talk more about that later, but just by that brief introduction, you see just kind of the different, just the different models that we went through as we developed this concept of the atom and its structure. So what do we think now? We know that the nucleus has two major parts, or excuse me, the atom has two major parts. We've got the nucleus, and in the nucleus we've got the positive protons and those neutrons that are neutral. And in the electron cloud around it, surrounding that nucleus, we have those negative electrons. Now, when you look at the size of these, the protons and the neutrons are almost identical. There's a little bit of difference. The neutron is just a teeny tiny bit bigger, more massive than the proton. Um, but the electron is incredibly small compared to those. Notice that the electrons are measured at 1/1800th of the mass of a proton or a neutron. All of those are measured in AMUs. AMUs are atomic mass units, a very small unit of measurement on the atomic scale. Now, when we look at the atom, there are some terms we need to be familiar with. The first is the atomic number. The atomic number is the number of protons in the nucleus of the atom. The number of protons we can find on the periodic table, the large number that starts with 1 and goes on up on the periodic table, that's the number of neutrons. That's what determines, I cannot emphasize this enough, the identity of the atom. If you have a neutral atom, the number of protons must equal the number of electrons because the positives and negatives have to cancel each other out in order for that atom to be neutral. So if you look on the periodic table and you look for the carbon, you will see that the big number on that periodic table is a 6, and that tells us that carbon has 6 protons. Well, if that's true, how many electrons does carbon have to have? Well, it must have 6. Since it's neutral, it has to have those 6 positive particles and 6 negative particles. The neutrons can change. It can have 6, 7, or 8 neutrons. We'll talk more about that in our next set of notes, but it has to have 6 protons. If it does not have 6 protons, it is not carbon. If it has 7 protons, if you look at your periodic table, then it's going to be nitrogen. If it has 5 protons, it's going to be boron. Protons must be the same. Another term that we have to be familiar with is mass number. Mass number is the protons plus the neutrons in the nucleus of the atom. The atomic mass, or atomic weight, is a weighted average of all of the naturally occurring isotopes of an element. Now, we haven't really talked about isotopes. We will in the next set of notes. Let's just suffice it to say that you can have different isotopes of carbon. They all have 6 protons. If they're neutral, they all have 6 electrons. But as I said above, they could have 6, 7, or 8 neutrons, which would change their mass number. And so when we average those together, that weighted average with the most often occurring isotope getting more weight on that average, then we're going to have what we call the atomic mass or atomic weight. So what do I expect you to do on the worksheet? You'll have a worksheet that looks something like this. And on this worksheet, you have usually 2 pieces of information. And depending on those pieces of information, you're expected to be able to come up with the rest of the information. So looking at this first one, if you've got 16 protons, what else does that tell you? Well, hopefully you remember if it has 16 protons, that if it's a neutral atom, which all of these are, it's got 16 electrons. Also, hopefully you remember that the definition of atomic number is that it's the number of protons. So the atomic number of this must be 16 as well. So if that's true, if this is the element that has 16 protons, which element is it? Well, if you look at the periodic chart and find number 16, you will see that it is sulfur, and that its symbol is S. Looking on the periodic chart as well, you should be able to determine its mass. Depending on the periodic chart that you're looking at, that mass may be a rounded to 2 or 3 sig figs. If you look at the fold-out chart that I gave you, you will see that the mass of sulfur on that fold-out chart is given as 32.066. So that's the atomic mass. Technically, I could put AMUs there, but I'll accept just the numerical value on this particular one. Number of neutrons, then, you have to keep in mind what we said about mass number. We know that mass number is the protons plus the neutrons. In this case, we know that the mass number is 33, and we know that the protons are 16. So how many neutrons does it have to have? Well, hopefully you came up with the fact that it needs to have 17 neutrons. See if you can do the next one yourself real quick before we do it together. Hopefully you came up with the fact that since it has an atomic number of 19, that it's got 19 protons. And since we're talking about all of these being neutral atoms at this point, that it must have 19 electrons. Well, if this is number 19, which element is it? Number 19 is potassium. It has a symbol of K. If you look at the fold-out chart I gave you, it tells us that potassium is 39.0983. AMUs. And if we look at a mass number then, coming up with our mass number, remember we just said that mass number was protons plus neutrons. And we find here that if we have 19 protons, which it tells us right here, so we've got 19 protons, we have 22 neutrons, then it looks like our mass number must be 41.